In the next four questions, 11 through 14, the directions say for each problem, find all points of absolute minima and maxima on the given interval. So in here I typed, just to remind you, absolute minima and maxima are found at critical numbers and or the endpoints of the interval. So really what we're going to do is we're going to find the critical numbers. And remember, critical numbers are when the derivative is 0 or undefined. And the endpoints. So we'll find critical numbers and endpoints. We'll plug them into the function and just see what's our highest and lowest number. So for number 11, first thing we're going to do is we're going to find the critical numbers. So we're going to take the derivative of this. So y prime is equal to negative 3x squared plus 8x. Derivative of negative 4 is 0. We'll set this equal to 0. Let's go ahead and factor here. We can factor out an x. And this is negative 3x plus 8. And so x either equals 0 or solving that, set that equal to 0, you get 8/3. So 0, 8/3 are the critical numbers. What we have here, though, we are only looking in the interval 2 to 4, so 0 is not even in there, so we don't have to worry about this. This is 2 2/3, which is an interval. So we want to check where our maximums and minimums occur. So let's plug in 2, we'll plug in 8/3, and we will plug in 4. All right, so when we plug into our function, we get negative 8 plus 2 squared is 4 times 4 is 16 minus 4. So that really is negative 12 plus 16, which is 4. So we get 2, 4. Put in 8/3. All right. So this is going to be negative 512, because 8 cubed is 512, 3 cubed is 27. Putting 8/3 in there, 8 squared is 64 times 4 is 256 over 3 squared is 9 minus 4. Okay, you can definitely do this on a calculator, I suppose. You can definitely do it by hand. So 512 27ths. That is negative 18 and 26 27ths plus 256 ninths. That's 28. We'll run into our next question, and 12 27ths, 28, 12 27ths, and then we have the minus 4. Well, really the minus 4 and the negative 18, so we can kind of put those together and make that negative 22. And combine those, and we get 5 and 13 27ths. So 5 and 13 27ths. That was quite a chore. Put a 4 in, so now we're coming down to our last one. Put in 4, you get negative 64 plus 4 times 16, that's also 64, minus 4. Oh, that's negative 4. And so it looks like our max is at 8/3, 5 and 13 27ths. That's our max. And then the min is at 4, negative 4. And so those are the two answers. I'm going to go ahead and let's move these over here because we have the next problem to do, and we'll put them in black. So that's the answer there. Sorry, I didn't leave enough room to do that work. All right, next, I'm just going to erase some of this work here. Number 12, same idea. We need to find the critical numbers. So we need to take the derivative. So y prime is equal to negative 1/3 times 2x minus 4. Subtract 1 from 1/3, that's negative 2/3. Times the derivative of what's inside, which is 2. So y prime equals really 2 over negative 3. I'm going to put that's a negative exponent, so we can put it in the denominator of the cubed root of 2x minus 4. So we can zoom in so that's a little easier for you to see. And we want to know either when this is 0 or when it's undefined, because we need to find when it's a critical number. Well, this actually never equals 0. For it to equal 0, we would need a 0 in the numerator, and there's no values of x that give us 0 in the numerator. Is it ever undefined? Well, first of all, cubed roots you can have negatives, so negatives aren't off limits. We can take the cube root of negative. However, it is in the denominator, so we can't make the denominator 0. So x equaling 2 would make this undefined. So x equals 2. The derivative is undefined. Well, that really doesn't matter to us because undefined. 2 is not in the interval we're speaking of. So we don't have any critical numbers within that interval. So what we will do now is we'll just try plugging in negative 7 and plugging in negative 1. So plugging in negative 7, put 7 in there, so that's negative 14 minus 4 is negative 18 to the 1/3. Well, the cubed root of a negative is negative, so we'll have a negative negative, which is positive, and we can just say this is the cubed root. It's a 30 cubed root of 18. And then plugging negative 1 in, put negative 1 in for x, that's negative 2 minus 4, which is negative 6 to the 1/3. Again, the cubed root of a negative is negative, so it's a negative negative, which is positive, so the cubed root of 6. And so therefore, we see that our max is going to be at negative 7 cubed root of 18, and the min is going to be at negative 1 cubed root of 6.